Hello everyone again. Now I'm going to talk about the second topic here, confidence interval for the regression coefficients. As I mentioned here before, population and sample, when we perform regressions, we always perform on the sample. So we get estimation, we don't get the true value. So parameters are always the true value. Statistics are the estimation, as you know. So we are always interested in when we repeat the sampling technique, are we going to get the same value, whether for the average or for the standard deviation or for the regression coefficient? The answer is definitely not, because every sample will give us totally different values. And we are not interested in the specific values coming from the sample. We are interested to know where are the parameters. So we can always know the parameters where they are, but we will never know their exact values. We can only estimate them and where they are. And the statistics will help us to give us a point where we can search around them to find the true value. Now let us go ahead and go to the regression coefficients. Regression coefficients, we're going to talk about regression. We have dependent and independent. So if we go to our famous case, we have the dependent variable here is basically the customer satisfaction, and we're gonna take one of the independent variables one by one, and I'm gonna show you how to do it for one or two variables, and then the rest you can do it by yourself. So I'm interested to know whether the product quality has an influence on the customer satisfaction, and not only has influence, because we always expect there is always correlation, but we don't know how the impact is. And we knew from previous discussions throughout the semester, with regression we can know the impact and the beta coefficients. However, we don't know if this beta is really different from zero or not, because if the beta close to zero, it means no correlation or no impact, in fact. So that means if this beta is really close to zero, then it means X, or product quality, doesn't affect significantly our dependent variable. In this case, why should we spend money on a variable that has no impact? So how can we judge that there is impact or not? We have to check the value against the zero, because if it's a zero, then it's not significant impacting anything. But if it's not zero, then it looks like we need to spend more resources on that variable in order to improve the overall satisfaction. So let's go ahead, take the two variables here. I'm going to take x6 and x19, just copy them, go to new sheet. I prepared a new sheet here called regression between x6 and x19. Let me put them here, Control V. I'm gonna just move this ahead here on the first column. It's easier for me to show you here. I'm gonna talk here about, this is the y variable. You know, this is the dependent variable, as you know. This is the independent, we call it x, as also, you know. Just let us put some values here, because when we get the regression, you can see the output here. This is the overall satisfaction. Just it's better to name your variables. It's a good habit here, product quality, because it will help you later on when you get some output, instead of getting the abbreviated variables like x6, x19. If you have few variables, it's okay, but if you have a large list of variables, you will get confused sometimes. So now, you know, I'm gonna go ahead to show you the regression. Let us go ahead, do it. You know how we do it. We go to data here, and then I call up here the data analysis toolkit here. So, and I'm gonna go ahead here to find the regression, and the regression asks me, Excel, where is your the y variable and the x variable? So I know them where they are. I'm gonna hint here. It's basically, I know that y is in a column, so but I start from A1 to A101, as well as here the B. In B column, I have the X values of the product quality. So I'm gonna write here B1 to B101. Of course, if you don't know where your data reside exactly, then you might really go ahead using the mouse. Now I have to be very careful here. I have to check the labels here, because I'm telling Excel, take care, the first row is not numbers, so ignore them. Now I'm gonna ask Excel to put the output in the same sheet in order not to go back and forth. So I'm gonna select one of the values here. I'm gonna select G, and then I push the bottom here. Okay. Of course, it will give me some error here, but just ignore it. In this case, it will not happen to you, but it happens here because I was writing something before in the same area, and Excel asked me, do you want me to rewrite? Yes, for sure, go ahead, Excel. So we know the deal here. This is the R square, as you know. I'm not going to go ahead and discussing the regression, you know it from before. Now we have a very important output here, and the output here is basically telling us this is the coefficient for product quality, which basically I can just write it again here. We can write here if we increase product quality, in this case X6 product quality, yeah, okay, product quality, whatever. If we increase X6, that means we have to do something, maybe pay money, improve the quality, changing some of the ingredients of our quality of our product to improve the quality of the product. Whatever we pay there, and if we manage to increase the quality, satisfaction, perception by 1 unit, if we increase X by 1 unit, then based on the regression, we can be promised that then the customer satisfaction, in this case X19 customer satisfaction, will increase by how many units, right? In this case is only 0.1415, this value. So it's a 0.4 unit, right? It's not even half unit, but at least on average, because you can see if we get another sample, this value for the same X6 and X19, we will not get exactly 0.415, we get something around. But in order to know how around we are, you see here Excel was very generous to calculate the confidence interval that we did already in the first video. Excel calculated already the lower and upper. So Excel tells us here, or this regression tells us, although based on the sample the value is 0.415, but if you repeat it again and again and again, different sample, the beta, the true value of regression, is more or less falls in this area. So instead of saying the 0.415, the least we can increase by 0.26 or 0.27. But if we are very optimistic, we're gonna get 0.56 and not even 0.415. So basically it tells us our range, but we are only confident with 95%. That means the value could be totally outside this range, but at least most of the time, that's why we say 95%, most of the time, our value will be in this region. But now this is a very clear here output. We know that from previous things here. But if we want really to check sometimes whether this 0.4 is negligible or not, because as you see, if our data are in millions, this number will not be decimal point, will be even in thousands. But in the end, we need to make sure that this value is not 0, because if it's 0, it means here, if we increase X6 by 1 unit, then X19 will increase by 0, which means basically X6 has no effect. Then why should really I invest money or resources on X6? So it's very important for decision maker, after they get this number, they check if this number is really close to 0 or not. Then I'm going to use the same idea here. I did before, so in order not to make this video longer for you, just let us go through the same thing. So in order to understand this part, you have to watch video number 1 first about the subject 1, otherwise you will get lost. So the confidence level, we keep it 95. alpha will be 1 minus this area, this value, then it's 0. It's 5%. Now our benchmark is not anymore 7.2 or 7.5 as in the previous video, but actually we want to compare this value. Let me make it colorful here. This value against, let me make it even, yeah, let me take this value against this value. Basically I'm trying to see if this 0.45 close to 0. To be honest, obviously it's not close to 0, but it's better to do this test always. Anyways, we need always the standard error, as you know, to calculate something similar. It's not the same function, but we need both of them. We need still the error margin here. Okay, so basically we need to calculate the standard error, and the standard error, it's basically, you can see here, it's already here. See, standard error is here. Oh. Calculate. So you don't need to calculate it like here, because we don't have the S, we have only S for both, and it's more complicated, to be honest. So it's already calculated here. Let me say it here, it's equal. I'm taking actually this value here, so I will write here calculated by the regression algorithm already. So calculated, oh, I wrote something here, calculated by the regression. So you don't need to calculate it, it's given. But the t-value, we need to calculate it, so you know it, the t.inv again, and take this two-tail here. Probability is alpha, degree of freedom is 99, it's already there. So then take the value here. You know the deal, E is now, I know the t-value here. I know now the standard error, so all what I need to do is to multiply both of them from previous one here is 0.149, and the lower limit will be basically very simple, the benchmark minus this value, and the upper limit equals 0 plus this value. So then the question is, yeah, this is actually outside. So if this value is close to this region, that means within this region, that means it's almost 0. So it will be insignificant, but you see here the conclusion is significant. There is an equation here. I'm basically testing if this value is really outside the region. If it's outside the region, then I can easily say if it's outside the region, then it's a significant impact. If it's inside the region, then it's not significant. You can always try to replace x6 by another variables and check these values and check the conclusion. You will always find out if the variable is really significant or not. So I can go ahead here. This is all what you need in this video. So basically what I have done here, I can show to you. I got the two variables here, dependent and independent. Then I applied regression. Then I get this statement looking at the coefficient here. But in order to judge if this is close to 0 or not, we need to calculate the confidence interval of the 0, and we came to this limits, which makes sense here. That means our 0 is not 0 exactly. Our 0 could be anything around this area, but our value here, it's outside, which is and positive. It means it's significantly impacting our value. That means product quality is really important. If we want to check another variable, why not? I will in the next 5 minutes, and this is it. I'm gonna check this into new one here. Let me take another one here, regression, and let us take let me take x8. Okay, let me put it here, x8. Let us see if it's significant or not. I will keep x19 the same. All what I need to do is get x8. So I'm gonna go ahead here, data set here. I'm gonna get x8. Let's see what's x8 is, but first let us drop it there in order to see what's going to happen here. Control V. Let's take the value here. Where is x8? Let's see, x8 is called technical support. I take it from here, Control copy, go back here, just change it here, for the sake of being more labeled in a good way. So why not do it like that? Okay. Unfortunately, once we put the data here, regression, it's not formula based. It's it's only one time. So I need to repeat this again for X things here. But let me do something here. If I go here, you can play with this statement if you want. So let me take this into equation. Why not? I do it for you. We say if we increase x6 in this case, it's not x6. Let me take the label from b1. Let me write it b1 here and then stop it here. If we increase this b1 by 1 unit, then I have to put again here, then x19. In this case, I can take, instead of x19 here, I can write a1, and then again another one will increase by, and then I can add another segment here of text. Let us put it here. This one is basically h18. So I will take this instead of h18, and you see it's already marked here, and then I can add another segment unit on average. So if I hit enter, we will get an interesting statement here, complete statement. The only thing is this one is really it's too much here. I can always control it, but now it's say if we increase x6, which is product quality, by 1 unit, then x19, which is the overall satisfaction, will increase by this value. If we want to keep this value to 3 decimal point, all what you need to do is to take this value, wrap it in a text function under Excel, and tell Excel what format you need. It's basically put it here. Let us put 0.3 decimal point. Let us see if it works. It works. Okay. Then it's 0.415. So if I take this value now, control copy, put it somewhere here in the new one, put it here. Definitely nothing changed because we didn't change yet. Now you see what Excel will be not happy with me, but I will do it anyways. I'm gonna go ahead here, data, regression, and all what I need to change is nothing, to be honest, because the B has now the data for X18, and I need everything. Even I want Excel to replace this data by this, but this is why Excel is going to create an error. But the error, Excel just asked me if I want to do it. See here, regression output range will overwrite. Yes, go ahead, I have no problem. Then okay, then we get different value here. Oh, Excel even, okay, let me take it again here, control copy, go back here. Let's see why Excel did that, but okay, now you see everything changed. If we increase x18 by this and so on, this value will increase by this, right? But let us see if this is really significant. Let us check. It's basically insignificant. Why? Because it's a 0.087, and our 0, it's between minus 0.15 or 0.16 and plus 0.16, and obviously this value is outside. So basically this statement has no meaning anymore because it's insignificant. I think if I do it again for the last time for another variable, so let me create another one, and this will probably be the last one. In this case, I'm gonna select x9 instead of x8, and I'm gonna go ahead again, get the data, take x9 in this case, control copy, back to the regression, and yeah, I'm doing very fast because you know what I'm doing here. So now I'm gonna, if I want the name here, I'm gonna go ahead here, take it here, control copy again, go back to the regression, and then put it here, labels. Maybe I can fix this by put it again to be consistent a little bit. So now we have our data ready to repeat it again, and definitely this will be disappearing, which is okay. Let's go ahead here again, data analysis, regression, everything is the same. Just push OK. Yes, go ahead. Now we get something here. Let me take this from here, control copy, drag it and just put it here again, and this is it. Let us see if it's significant or not. It's significant. It's again, our 0 is between -15 again, 0.15 and 0.15 as well, 0.7, something like that. But here the value is really outside, so it's a significant impact. Wow, I like this method. Now I hope you understand what we're doing here. So then it makes sense that we invest in X99, which is the complaint resolution, because once we invest in it, we're gonna get some return, which is this value on X19. I think I finish here. All what I did in this 2 videos. The first one I explained to you how we calculated in details. Now I use the same concept to calculate for regression coefficient and to know whether our data are significantly from 0 or not. I covered as well the population and sample again for you and how we use this function. So I hope it was useful. Take care. This will be part of the all quizzes, upcoming quizzes, in this case quiz 5, or as well as the final examination. Good luck, guys.